we enter into the last chapter of the semester. So we talk about probability distributions. Now, see how this works. There's a random variable. It's kind of what you're talking about. Like if you toss a die once, then x could be the random variable 1, 2, 3, 4, 5, 6. If you flip a coin, x could be the random variable h or p. It just you designate a variable. It's a function that assigns a real number to each outcome. So it's essentially like a variable. It changes. So you assign an x value. A little bit of algebra. So if you toss a die once, your sample space essentially are 1, 2, 3, 4, 5, and 6. The probability of each of them happening is 1 out of 6. So probability of 1, 2, 3, 4, 5, 6. There's 1 out of 6, 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 1 out of 6. This is actually called a probability distribution function. That's what this is, a probability distribution. So this is a probability distribution where it takes all the values of sample space, gives it a name, and designates all the probabilities of that sample space. So this whole probabilities should add up to 1, or 6 out of 6 here in this case, where x is the outcome when you toss a die once. So if you toss a coin 3 times, these are the results. So now in these results, you can let x be maybe the number of heads that you can get. Well, you can get no heads, you can get 1 head, you can get 2 heads, or you can get 3 heads. So x would be the variable 0, 1, 2, 3, the number of heads you can get when you toss a coin 3 times. So the probability of getting no heads is TTT, 1 out of 8. The probability of getting 3 heads, 1 head, THT, TTH, and HTT, 3 out of 8. The probability of getting 2 heads, THH, HTH, and HHT, 3 out of 8. Probability of getting 3 heads is HHH. So 1 out of 8, 3 out of 8, 3 out of 8, 3 out of 8. Notice that if you add all of this, you get 8 out of 8, or you get 1. In terms of a decimal, 1 out of 8 is 0.125, 3 out of 8 is 0.375. So these are decimals, the same equivalence. If you add these 4 decimals, you get 1. So this sigma, or this E thing, represents the sum of all the probabilities. So in a probability distribution function, or probability distribution, the sum of the probabilities has to add up to 1. If it doesn't, it's not a correct distribution function. There might be some rounding off error where it's like 0.99 or something, but typically it should be a 1. Then you talk about expected value. Again, this is just a distribution of, if you get a sample space and you look at each probability, you list the probabilities of each type of thing happening. So I list the possibility of getting 0 heads, 1 head, 2 heads, or 3 heads. That x be the number of heads occurring. So expected value is actually another way of saying the average. So you're going to actually take each x value and multiply by the probability of that x value. So you're going to multiply probability times x value. That's what you're going to do. You're going to multiply the probability times the x value. And then you're going to add them all up. So that's what this fancy thing says. So it's x1 p1 times plus x2 p2 plus x3 times p3 plus dot 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 xn times pn. So it's basically 1 times 1 over 6, 2 times 1 over 6, 3 times 1 over 6, 4 times 1 over 6, 5 times 1 over 6, 6 times 6 over 6, and I'm going to add those 6 answers up. That's the expected value, where n is the number of random values that you have. It depends on the number of x's that you have. So this is the sum. This is actually kind of what the average would look like. So let's see. Compute the expected values. So if I give you this probability distribution function, notice that x is 0, 2, 4, 6, 2, 4, 8, or 16. 0.21, 0.24, 0.21, 0.17, 0.7. These are the probabilities of that thing happening. So if you add up all the probabilities, that adds up to 1. So this is a valid probability distribution, or probability distribution function. So the expected value would be the first x times the first probability plus second x times second probability plus third x times third probability, and you keep going until you finish the products. So you put all that into your calculator, and it should give you 73.4. essentially. Let me go ahead and do that. Maybe I just, it actually doesn't seem, I think my decimal is off here, but let's see. Give me a moment here. And again, I realize that I'm talking to myself, but it's still a video for you guys. Yeah, that was super off. It's actually 5.4. I don't know where the heck I got 73.4. Man, maybe I was tired. I don't know. Just no excuse. It felt wrong because the expected value is kind of like the average, kind of like a weighted average, if you will. So here, let me put the arrow. The expected value of x is 5.4. So if you were to run this experiment or you were to run an event, you would expect to get somewhere between 5 and 6, which is kind of heavy, kind of right, because you're close to the middle here. So 5.4 is actually the expected value. I don't know why I put 73.4. Forgive me for that. This one, according to a recent report, 80% of U.S. households own a gaming device of some sort. If 5 households are selected at random, the probability distribution for X, the number of households who own a gaming device. So out of the 5 households, there's a 0.0003% chance that nobody has a game. That's very rare. That there's only one gaming system, 0.0064. That there are 2 gaming systems out of those 5, 0.0512. There's essentially a 20% chance, or 0.2048 chance that all 3 out of 5 have. A 0.4096 chance that there are 4 games in that household, and a 0.3277 probability that 5 of the households, all 5 have a gaming device, at least one. So find the expected value. So again, 0 times 0.0003 plus 1 times 0.0064 plus 2 times 0.05212 3 plus 3 times 0.2048 plus 4 times 0.4096 plus 5 times 3.277. And I guess since my confidence is kind of shaken a little bit, let me do this. 0 times, not that you have to do the first one because you're going to get a 0 there, but it doesn't matter here. I'll do it anyway. Plus 1 times 0.0064 plus 2 times 0.0512 plus 3 times 0.2048 plus 4 times 0.4096 plus 5 times 0.3277. So it's, my confidence was shaking a little bit, but there it is, 4.0001. So it's about 4 on average, which makes sense that out of 5 households, 4 of them on average are going to have at least one gaming device, which makes sense because that's what you expect, 80%. So on average, you expect 4 out of 5 households to have a gaming device. So that's the average. That's what you think. So this checks out. So I just wanted to point that out there. That's actually pretty good. Number 9.2 and 9.3. Now you actually get into, if I may, give me a second, permutations and combinations. Now, this is how you're actually counting things. So we're going to get away from probability a little bit. We're figuring out how many ways to count something. So if there are n number of choices and there's m1 ways to make choice 1, m2 ways to make choice 2, all the way to mn ways to make choice n, then the number of ways to make all of these choices one after another is to multiply everything out. So let me explain that with the next few problems here. Suppose Andrea has 8 skirts, 9 blouses, and 12 pairs of shoes. If she is willing to wear whatever combination, in how many different skirt, blouse, shoe choices can she dress herself in? So the total number of choices, she has 8 skirts times 9 blouses times 12 pairs of shoes. So she has 864 ways that she can get dressed. So that's what this is. Essentially, it's saying the counting principle says the number of each multiplied. So 8 times 9 times 12. In a store, there are 20 refrigerators, 15 gas stoves, and 35 dishwashers for sale. If Bob needs exactly one of each from that store, how many possible choices are there for Bob to choose from? Well, 20 refrigerators times 15 gas stoves times 35 dishwashers. He's got 10,500 choices. In a multiple choice test, again, there's 4 choices for each problem, let's say A, B, C, and D, with 10 problems. How many total possible different tests can be submitted? How many total tests can you rearrange? Or how many possible, when you turn it in, how many possible different outcomes, how many possible different choices can you put? How many different tests can you be turned in? Well, there's 4 ways of doing the first problem, 4 ways of doing the second problem, 4 ways of doing the third problem. There's 4 ways of doing each of these 10 problems. So 4 times 4 times 4 times 4, 10 times, or 4 to the 10th. So there's really over a million ways that people could turn in a test. A 10 question multiple choice has over a million different combinations. It's crazy. But people make educated guess, or they study and kind of, they how do you say, they push the odds in their favor. So the probability of getting 100, if you guess, is 1 out of 1,048,576 choices. Good luck guessing. You know, the probability of getting 100, if you guess, is 1 out of that. There's only one way you can get 100, by getting them all right, divided by the total number of ways. So those are your odds of getting 100 on a 10-question test if you guess at one, if it's multiple choice. Yeah, good luck. Then you talk a little bit about factorial. Factorial is the idea essentially of n with an exclamation point. So this is, it's not exciting. That doesn't mean it's excited. It just means any number with an exclamation point, it's like you're going to count backwards and multiply all those things out. 0 factorial is defined as 1, and 1 factorial is 1. After that, then it's that number times 1 less, times 1 less, times 1 less until you get back to 1. So 3 factorial would be 3 times 2 times 1, or 6. 5 factorial would be 5 times 4 times 3 times 2. In other words, you're counting backwards all the way to get to 1. 10 factorial would be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Or 3,628,800 ways. Now, I'm not saying to go out and get a calculator. By any means, I'm not saying that to get one. But if you have a graphing calculator, let me clear this. Let's see if I have this right. Under math, there is PRB. Notice the little exclamation point. So let me quit. So I put 3, and then math, and I scroll over to PRB, then I go down to 4, and then I hit enter. So 3 to the 3 factorial is 6. If you wanted 10 factorial, just for the sake of argument, you don't have to do all the work here, but it's a built-in function. See that? I'm not going to make you multiply all that by hand, but you can actually do this in the calculator. It's not that bad. If you have a graphing, don't go out and get a graphing calculator just for this. But if you're going to use business, if you're going to go into business field, a graphing calculator is good to have for future. But I'm not saying to go and get one for this. Okay, just a couple of problems here. So D has 50 factorial over 48 factorial. So if you think about it, 50 factorial means 50 times 49 times 48 times 47 all the way through. So the top part is essentially 48 factorial. This part, 48 backwards. This part is essentially 48 factorial also. So all of this cancels with all of that. Everything on top cancels everything on the bottom. All that survives is the two extra numbers that 50 is counting backwards. So you count backwards, 50, 49, then 48 and back. Well, that's where you catch the bottom. So 50 times 49, you get 2450. So if you wanted to on the calculator, 50 math prob 4 enter divided by what was it, 48 math PRB. That's it. So I could do just as much by hand as I could essentially by the calculator for the most part. And again, like you look at this, 98 factorial divided by 100 factorial. 100 factorial comes back from 100. So at 98, it catches the top. So all this cancels, and essentially I have a 1 left. So I have 1 over 100 times 99. So I have 1 out of 9,900 choices. 1 out of 9,900. That's what this divides to. So I'm going to give you an idea of how factorial works. So suppose there are 8 students and 8 desks, and you want to fill them out one at a time. How many different ways can you fill out the desks? Well, if you take desk number 1, essentially you take desk number 1. There's 8 choices, 8 students you can pick from. Then if you put a student in there, the second desk you have 1 less student to choose from. Put a second student in there, the next desk you have 1 less, 1 less, 1 less. So this is factorial. So there's 8 desks and 8 people. So there's 8 factorial number of ways to do this. So 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, or 8 factorial is 40,320 ways. If you have a 4-digit password, the only numbers you can choose from are 1, 2, 3, and 4, and you can't duplicate them. There's 4 ways to choose the first number, 3 ways to choose the second number, 2. So 4 factorial will tell you all the combinations here without repeating itself. So 24 passwords. Okay. How many ways can you rearrange the word mat? Well, there are 3 words. There's 3 letters. So the first one, there's 3 letters to choose from. I choose one. Second time, I only have 2 letters to choose from. The third time, I only have 1 letter to choose from. So there's 3 words, 3 letters, 3 factorial. In fact, these are the 6 ways. So 3 factorial is 6. In fact, what we are doing here are actually called permutations. We're actually permuting n things n number of ways. So it's n factorial. But sometimes maybe you have 8 desks, but maybe you have 8 students, or maybe you only have 4 desks, and you want to figure out how many ways can you put 4 of those students in there. 8 students, only 4 at a time. So that's what the next part is about. So we have 2 things. One thing is called permutation, and one thing is called combination. So in 9.2, you talk more about permutations. In 9.3, you talk more essentially about combinations. Or you really talk about permutations in 9.2 and 9.3, a little bit of both. So a permutation is the number of permutations of an object, of n objects taken r at a time. So the symbol is NPR. N permutations r at a time. N factorial divided by n minus r factorial. So there are 12 players in a basketball team, but you only want to choose 5 at a time. So if there's 5 starting lineups, 5 people that you could start. Let's see. Essentially here, you want to do this. Let me see here. You want to do 5 players at a time. So in a basketball, you have center. Let's say guard 1. Let's say guard 2. Let's say you have forward 1, and you have a second forward. I mean, it varies with the lineup you want to have, but notice that there are 5 types, there are 5 positions. Center, there's the first guard, the second guard, the first forward, the second forward. There's 5 positions. So out of the 12 people that are on the team, you want to choose 5 of those positions. So guard, center, that kind of stuff, and you want to get in there where you pick them matters. So it's permutations. So 12 factorial divided by 12 minus 5 factorial. Again, n is 12, r is 5. So following the formula. So this is really 12 factorial over 7 factorial. Now if you think back, when you count backwards from 12, you catch 7 here. So 12, 11, 10, 9, 8, 7 factorial. 7, 6, 5, 4, all that 7 factorial. So that's going to cancel with the bottom. So immediately once you catch 7, you kill the bottom. So it's 12 times 11 times 10 times 9 times 8. Instead of going all the way down, you cut off the rest. So 12 times 11 times 10 times 9 times 8 is 95,040. Now I get it. If you have a calculator, you want to make this a little easier on yourself. Now, I'm not saying to go out and buy one, but let me show you how to do this. 12, math, PRB. You see number 2 there, NPR, 5, hit equals. Or you could do like me, where I cancel stuff out and I multiply that out. So it's a built-in function in your graphing calculator if you have one. If you don't have one, just multiply it out. It's not that bad. There won't be a lot of these problems in the test, just a few. So like I said, don't go out there running for a calculator unless you want to use it later on in your other business classes. You can go ahead and do that. Now imagine 50 numbers in the lottery. 6 numbers are chosen at random. How many possible lottery combinations are there? Now, essentially here, this is actually kind of more of a combination problem, but because that's how many combinations there are. However, if the order matters in the way you pick the lottery, if you have to pick a certain ball in a certain order, then this will be a permutation. Let's kind of assume that here. So out of 50 lottery numbers, you have to pick 6 of them correct. So 50 factorial divided by 44 factorial. Again, 50, 49, 48, 47, 46, 45. You catch 44 right here. So 44 factorial cancels. So there's 6 numbers. First one has 50 shots. Second one is 49. Third one is 48, 47, because you're going to pick one each time, making it one less. So you multiply all that out, and you get this mess. Now the problem is my calculator doesn't go that far. However, I'm going to do this here. 50 times 49 times 48 times 47 times 46 times 45. And I get this e to the 10 thing. What it means is move the decimal 10 spots. So there's only, 7 spots to move it? 1, 2, 3, 4, 5, 6, 7. So I add 3 zeros at the end. It's about as close as I can get to it. And again, if you do 50 permutations, taken, 6 at a time, you get the same answer. So roughly, it's about what? My calculator doesn't even go that high. It's about 11 billion ways. Over 11 billion ways to win the lottery. So you have a 1 out of 11 billion chances to win. Good luck. I tell my students, yeah, good luck trying to win the lottery. But yet somebody wins it every once in a while. So that's why the odds are against you, and that's why. In other words, for every 1 chance in your favor, you have 11 billion against you. So the odds of you winning are very, very tiny. But that way, when you win it, you get a huge chunk, and that raises the expected value. So in a class of 10 students, a committee of 3 people are chosen at random. 1 for president, 1 for vice president, 1 for treasurer. So out of 10, you're going to choose 3 to fill this committee as a president, vice president, and treasurer. So the order matters the way you choose them. So 10 permutations of 3 people. In other words, 10 permutations taken 3 at a time. So 10 factorial over 10 minus 3 factorial. 10 minus 3 is 7. So 10 times 9 times 8 times 7 divided by, 7, 6, 5, 4, 3, 2, 1 divided by 7 factorial on the bottom. So 10 times 9 times 8 is 720. Or you could do like I showed you in the calculator, 10 permutations of 3. In fact, I don't know why I put a C here. I kind of jumped the gun. It's another permutation problem here. 9-horse race. How many ways can the top 3 horses finish? First, second, and third. Well, there's 9 horses taken 3 at a time. So 9 factorial over 9 minus 3 factorial, that's 6 factorial. Again, 9, 8, 7, you catch 6 here. So 9 times 8 times 7, 5,000, that 5,040 different ways. So let me see here. See if I can see that. 9 times 8 times 7. Wait. 504 ways. There's an extra 0 there. 9 times 8 times 7, excuse me, 504 ways. Not 5,040 ways. Let's do it like that. For some reason, I keep throwing an extra 0 there. But that ultimately is how you would handle the permutation. Now, there's another such thing, what's called a combination. Now, a combination is a different formula here. It's n factorial divided by n minus r factorial divided by r factorial. Now, that formula right there is permutations. But here you're going to actually weed out an extra r factorial because here the order doesn't matter. So you can have repeats over and over. So having the repeats, you want to weed them out. So the order doesn't matter here. So you're going to weed them out. So in a horse race of 10 horses, in how many ways can the top 3 finish? Now, I don't care who finishes first, second, and third. So horse 1, horse 2, horse 3. If let's say horse A, horse B, horse C, and then horse B, horse A, horse C, horse C, horse B, horse A. All those different combinations are the same combination, just one choice. Because I'm just looking at how many ways the top 3. So this thing says I want to pick 3 horses at random. Doesn't matter which 3. Just want them to be there. So if you mix up the order, you're going to show a lot of repeats. But in the previous one, whoever wins first, second, and third, A, B, and C, or A, C, B, that's a different combination. It's a different permutation. So where order doesn't matter, we divide by the extra r factorial. So this is 10, choose 3. So 10 horses, choose 3 at a time. So n is 10, r is 3. The formula, 10 minus r factorial on the bottom, 10 minus 3 factorial, and then r factorial is 3 factorial, and then n is 10. N is 10 factorial, then 10 minus 3 factorial. So 10 minus 3 is 7. Now, when you count backwards, 7, 6, 5, 4, 3, 2, 1, you count backwards, 10, 9, 8, 7, 6, 5, 4, 3. So this 7 factorial cancels with most of the 10 factorial. So I have 10 times 9 times 8. I have 3 times 2 times 1. So 3 goes into 9 3 times. 2 goes into 8 4 times. So all I have left is 10 times 3 times 4, or 120 ways. If that seems like a lot of work for you, 10, math, prob, NCR, 3. Okay? I like to work it by hand. That's just me. I like to cancel, but it's built in your calculator. That's why they charge you a lot of money for it. The next one, if I have 9 students and 3 people are chosen to form a committee, don't care who's the president, don't care who's the vice president. So I have 9, choose 3. So 9 factorial over 9 minus 3 factorial times 3 factorial. So this is 6 factorial. So counting backwards, 6 is bigger than 3. So 6, 5, 4, 3, 2, 1 is going to kill all these numbers off the 9 factorial. So I have 9, 8, 7 divided by 3, 2, 1, which is the other one. So 3 goes into 9 3 times, 2 goes into 8 4 times. So 3 times 4 times 7 gives you 84 ways I can form this committee. Then a sample of 5 light bulbs is chosen from a batch of 15. And how many different samples can be chosen? or how many different samples can be chosen. So out of the 15 bulbs, I'm going to just choose 5. It could repeat randomly. So 15 factorial over 15 minus 5, which is 10 factorial, times 5 factorial. So it's 10 factorial. When I count backwards from 15, I'm going to catch a 10 right there. So I'm going to have 11 to 15 backwards. And then I have 5, 4, 3, 2, 1. So I'm going to take 5 into 15 3 times. I'm going to say that 4 times 3 is 12. So that's going to cancel with this 12. This 2 is going to go into 14 7 times. So I'm going to have 3 times 7 times 13 times 11. Or 3003. Now, if you're not sure about that, again, 15, math, prob, 3, or NCR. Okay, 3003 ways. Same difference. Like I said, don't go out there buying a graphing calculator just to do a couple of these problems. If you're going to use it for later in your business classes and your business tests, and your executive exam for business, that's fine. Go ahead and do so, but not for this class. Not if it's just for me. Again, you don't need my blessing. You can do this if you want. So finally, I'm going to end the semester with this. I decided not to do the word problems in 9.4 or 9.3. There's some word problems here. I'm not going to really do much of the 9.3. I'm going to show you this. This is actually kind of cool. This is just kind of for us, but still, I might find some problems in here for this. So suppose there are n objects, n1 of type 1, n2 of type 2, n3 of type 3, and all the way up to nk of type k. The number of different arrangements or permutations you can do for these objects is n factorial divided by n1 factorial times n2 factorial times n3 factorial, all the way multiplied to nk factorial. It sounds funky. So I'm going to show you through these problems how this is really done. Okay. Let's see if I can kind of squeeze it down here a little bit. So the word nunnery, N-U-N-N-E-R-Y. Notice at the n, let n1 be the number of n's you see. Let n2 be the number of u's, n3 be the number of e's, n4 be the number of r's, and n5 be the number of y's. Notice that there are 3 n's in this word, and there's 1 of each other letters. There are 7 letters total, so n is 7. So 7 factorial divided by 3 factorial times 1 factorial times 1 factorial times 1 factorial times 1 factorial. But all of these 1 factorials are just 1s, so it's really just 7 factorial over the number of repeats here, 3 factorial. So 7 times 6 times 5 times 4 divided by 3 factorial. So 7 times 6 times 5 times 4. There's 840 ways you can rearrange the word nunnery. Kind of cool. Kind of different, I guess. So let's try that here with business. We're in a business class. So in this word business, notice that there are 3 S's. S, S, S. Every other letter appears only once. So in the calculations, they're going to be dividing by 1. They're not going to do anything. So you only worry about the repeats, in this case S. So 8 factorial divided by 3 factorial is 8 times 7 times 6 times 5 times 4 times 3 factorial. The 3 factorial is canceled. So I'm just going to really multiply 8 times 7 times 6 times 5 times 4. There's 6,720 different ways you can rearrange the word business. Now, they won't all be words, but you can rearrange them in that fashion. Statistics. There's 3 S's, S, S, and S. There are 3 T's, T, T, and T. There are 2 I's. Essentially, there are 1 C and 1 A. So these are the 3 repeats. There are 11 total letters here. So 11 factorial divided by 3 factorial, 3 factorial, 2 factorial. Now 1 factorial does nothing, so these 2 don't really matter. So 11 factorial, 11 all the way back to 1. So I'm going to cancel the 3 factorial with one of the 3 factorials. The 3 times 2 times 1, I'm going to take the 3 times 2 and cancel with a 6. I'm going to take the 2 here and cancel with a 10, leaving a 5. So I have 11 times 5 times 9 times 8 times 7 times 5 times 4. 554,400 ways. Now, if you want to know how to do this with the calculator, probably shouldn't be showing you. Actually, you should have to do it on your own, but nonetheless, 11 math prob factorial divided by, now we gotta be careful because all this stuff's gonna be multiplied. So parentheses 3 math PRB factorial times 3 math prob factorial times 2 math PRB factorial, close it, and hit equals. What did we get? That's it. 554,400 ways. That's how many ways you can actually change. You can actually rearrange these words. Pretty cool. Pretty interesting. Now there's some more stuff in 9.3 that talks about if you want to get a full house or if you want to get a pair, you want to be gamblers. What's the probability that you can get a full house? What's the probability that you can get 5s over 2s? What's the probability you get two pairs? What are probability? So it takes combinations, it takes factorials and divides by factorials. Like it takes the combination problems and divides by another combination problem, and multiplies by which is great, but you don't need to be really strong in probability to understand business. This is kind of more or less what you need to go into your next classes. So now you probably already saw it, but this is the last of the notes this semester. We have come to the end of our semester, the end of chapter 9. It's been a crazy semester. It's been great. It's been a lot of work. Proud of you guys. After you read this, after you watch this video, all that's left is take test 4, and of course finish the homework and quizzes, but take test 4 and the final after this chapter. And then we are done for the semester. Essentially, we made it through. We're almost there, so finish strong. Good work, everyone.